Okay, so going over this one. Our equation is 7x squared plus 3x plus 3 minus 7x squared plus 5 equals 8x plus 17. Now looking at this one, it looks complex because you see that x squared in there that tends to throw you off. You start to think, well, we don't know how to solve things with x squared yet. But remember, the first step is always to simplify what you can on each side of the equation. And on the left side of the equation over here, we have polynomial subtraction, or algebraic numbers being subtracted. And the way we do that is we just write them out and line them up. So 7x squared plus 3x plus 3, and we're subtracting here, but we're going to line up the 7x squared goes under the other x squareds. The 5 goes under the 1s, like that. So we're going to leave a gap in there to keep things lined up. Now we are subtracting. What is 3 minus 5? Negative 2. 3x minus nothing? Just 3x. It's positive, so I'm going to put a plus in front of it. 7x squared minus 7x squared cancels out. It's gone. So on the other side, we still have 8x plus 17. And now this looks like something we have solved a couple of times before. What do we do with it?
You subtract the 3x from the 8.
Okay, yeah, we either can subtract the 3x and get rid of it, or we could subtract the 8x and get rid of it. Some people like working with the numbers on one side or the other, but we prefer to get rid of the smaller ones, so we're working with positive numbers instead of negatives. So we're going to get rid of the 3x. Yeah, so 8x minus 3x is 5x, and we still have the positive 17. And at this point, if you really like, if you're one of those people that has to have the variable on the left side, you're right, Cody, you can flip it. Put the right side over here, as long as you keep it all together, it goes on the left, and the left side can be put on the right like that. So either way, what do we have to do next? We subtract 17, which gives us negative 19 equals 5x, and then divide by 5. Negative 3.8 equals x, or sometimes known as a negative 3 4/5.
Yeah, did that. I went negative 3.8.
And it marked you wrong?
Oh, yeah.
Yeah, because technically, according to the computer, you didn't learn decimals till the next lesson. And as far as the computer is concerned, you don't know decimals yet until you get to the homework from yesterday. What's that?
I went in here, I see skipped ahead by 3.
Oh, sure. Oops.
Okay, so.
Yeah, I see. I went to homework 8.
Okay, next ones. Let's peek and see what we got going here. Like I said, if you see one you want me to do, just yell out. Oh, this one I want to do.
Yell out?
Okay, just say something. In your case, no, Cody, don't yell. We experienced that last semester where we're never sure what you're going to yell, so no, we don't want you to yell. So here, just like before, we have the left side that we can simplify. So this is x squared plus 5x minus 1. And we are still subtracting. The 4x has to go under the 5x, and the 5 has to go under the negative 1. And we are subtracting here. Negative 1 minus 5. Now be careful, that's negative 1 minus 5. Is going to become a negative 1 plus a negative 5, otherwise known as negative 6. Because we're subtracting, see? So now 5x minus 4x. 1x, or just x. That's a positive 1. And then we have the x squared. Now you might be wondering, the x squared didn't disappear on us. Oh no, what do we do? Yeah, in our next step, we've got an x squared on each side. We're going to subtract x squared. It is gone on both sides. So now x minus 6 equals a negative 7. And now we will 6. Negative 7 plus 6 is negative 1.
Wait. Isn't x already isolated?
Yeah, it is. So you just have to, it's x minus 6, though, so you have to add the 6 to get rid of the negative 6.
Okay,
X squared is gone, but you still have the x.
x is a known.
Any other questions? Okay, well, back to the drive here. Oops, sorry. Okay, it's back here. Here's where we started to have some problems. Let's get one just a little bit more difficult than that. I'll get one that's a little more fun. I guess maybe these are as bad as it gets. Huh? Let's solve this one. Now, remember we talked about 2 ways we can go about these. This one here, the first thing we got to look at is we got to decide, is there a variable in the denominator? Is there a variable on the bottom of any of our fractions? And in this case, yes or no? No, there's no variable on the bottom of the fraction. So if that's the case, we actually have 2 options. We can just solve it as those fractions, or we can do what we've done before and do the common denominator and get rid of them, get rid of the fractions. So here we have 2x plus 3 halves, which of course we know could reduce to 1 1/2, equals 11 thirds. If I were just going to solve this with fractions, I would convert those improper fractions, the 3 halves and the 11 thirds, into mixed numbers, and I would do my subtraction, division, whatever. If I wanted to just get rid of them using the common denominator, I would leave them as they are and go that route. What would the common denominator of 2 and 3 be? 6. So I'm just going to use a common denominator to get rid of the fractions. I would multiply this whole thing by 6. Always multiply by the common denominator. So now I have 6 times 2x, which is 12x. 6 times 3 halves. I'm going to write out 6 over 1 times 3 over 2 is 18 over 2, otherwise known as a positive 9. Equals sign, then. 6 times 11 over 3, well, again, 6 over 1 times 11 over 3. Now, you asked it yesterday, Cody. I'm going to answer it again. The 6 and 3, you could cross-cancel if you wanted to. Just for the sake of time right now, I'm just multiplying it out. 6 times 11 is 66. Divided by 3 is 22. And we now have an equation that we can solve.
What's also the case, you don't need to cross-cancel like these.
Yeah, you don't need to cross-cancel them.
Your head works at the computer.
True, and most of you guys are going to be working on the calculator anyway. So. But the reason I didn't cross-cancel is because when we get the variables in there, sometimes it's a little tricky to cross-cancel. So now what do we do down here? We'll subtract 9, so 12x equals 22 minus 9 is 13. And then, well, no, we divide by 12. It's 13 divided by 12, not 12 divided by 13. You gotta be careful. So either 1 and 1/12 or 1.08333333. Any questions? To do these on the calculator?
I thought you were going to show us how to put something in.
Fractions?
Yeah.
Yeah, we did that, didn't we, a little bit?
Oh, yeah, we know how to do that. There was
Okay.
something else you were going to show us.
Let's do this one for you. So we've got 3 plus 9 over x plus 3 over 5 equals 7 over 2x. So we've got x, 5, and 2x. And yes, I know we did this example yesterday, but I want to do it again. What's our common denominator going to be? First of all, we got the 5 and the 2 are the number. Well, 1, 5, and 2 technically are numbers. What's that common denominator for the numbers going to be? 10. Good. For the variables, well, x would cover it. Remember, we look at the variables, and for each, if there's more than one variable, we look at each variable, and it's the highest power for each. Well, the worst we have is just an x, so x is its highest. X to the 1 is the highest power. Yes, sir?
Okay, but what if we had, for example, y to the second, x to the second? Then
That'd be y to the second. Now, you'd have to use both of them in their common denominator.
What's that called again? That's more, what's that?
Highest power of the x. The 10x is the least common denominator. Yep. So now we're going to, and since we're solving equations, there's going to only be one variable anyway, Cody, because we don't know how to solve equations with two variables in them yet. Yeah. We're not going to actually get to that in this class. Two variable systems of equations would be something that would be in whatever your next class is, if it was something you were needed for your program. So if you're going into like architectural design or wood construction or something like that, you would learn how to solve two variable systems of equations. If you're going into business, you're not going to see that. You're just going to get business math. Okay, so we've got the 10x as our common denominator. We're going to multiply by it. So 10x times 3 is, otherwise known as 30x. Good. 10x times 9 over x. We're going to make this 10x over 1 times 9 over x. We multiply that out. 90x over x. The x cancels out. That's just 90. Very good. Now we've got 10x times 3 over 5. So 10x over 1 times 3 over 5. 10x times 3 is 30x. 1 times 5 is 5. 30x divided by 5 is 6x. Next we have 10x over 1 times 7 over 2x. Multiplying that out, 10x times 7 is 70x. 1 times 2x is 2x. The x's divide out. 70 divided by 2 is 35. Now we have an equation that's simpler to solve. What do we do? So the 30x and the 6x combine to make 36x. So the plus 90 equals 35. So we're going to subtract 90. Where did my 36 go? Okay. Now we're going to subtract 90. That's gone. We still have 36x here. Subtracting 90 here gives us 55. And then other way around, 55 divided by 36. Should be negative 55. Is that better? Okay. So we got negative 55 divided by 36 is negative 1 and 1936. Negative 1.5. Good enough. Negative 1.5277. Yeah, close enough. I'm not on top of it today. Yeah. Some days the hamster doesn't crawl all the way on the wheel. He just lays beside it and tries to swat it with his paw. So it's not moving real fast today. Just to start off with. So here we have, it says, 2 times a number increased by 9, the result is 17. So the first step is to write the equation. What's it going to be? Now, first thing we have to do, since this is my math lab, is if we don't look down here in the fine print, we're going to get it perfectly right, but it's going to mark it wrong because we're going to use the wrong letter. It says, in the equation, use n. So this is 2 times a number will be 2 times n instead of 2x. So just a little warning, my math lab is very finicky like that. Increased by 9, so plus 9. The result is 17. What does that mean? Equals 17. So the first step is to fill in the equation. So when you do it into my math lab is forgiving about spaces, but it is not forgiving about the letter. So it's 2 times n, or just 2n, plus 9 equals 17. Excellent. You actually got to look down when you do that. Don't do that. You're keeping me out, Cody. So next we solve for n. So we're going to subtract 9. 2n equals 8. Divide by 2. N equals 4. Fantastic. You guys okay with those? Anybody struggling with them? Want me to do some more examples?
That's the quiz.
No, this is off the homework. This will be similar to the quiz that you're going to take next Monday and Tuesday. So I wanted to go over these because I know that to me, the most difficult part of these is just getting the equation. So something like this. The sum of 3 and a number is multiplied by 8. What does that mean? The sum is multiplied by 8. Means we're doing what first? Are we multiplying first, or are we adding first? When it says the sum is multiplied, that means we're adding first. So 3 and a number means it's 3 plus that number. So somewhere in parentheses, we have to have 3 plus that number. So we have 2 of them. So it's either the first choice or the third choice here. But which one of those is showing it being multiplied by 8? The third choice. So we don't even need to read the rest of it. That's the only choice that even fits so far. But we can. The result is 48. So equals 48. That fits. So that was correct.
Because it's aligned in the order it's aligned, do we really need the parentheses? Because it says
Yes.
3 plus n times 8.
Because order of operations says you would multiply before you would add. So you have to use the parentheses to specify that we're overriding the order of operations with our enclosing symbols. And then, of course, if you wanted to solve that, you could. I'm going to trust that you guys can solve the equation once you get to that point. Okay, so this one, it's asking the length of the first side is. So we need to find the length of each of these sides, but to do that we have to find x. Well, how on earth can we do that from the information we're given here? It says the perimeter is 132 feet. Well, remember, we talked about this yesterday. There are 3 types of problems. They either add up to a sum, they subtract to give us a difference, or they're equal to each other. In this case, we're talking about perimeter, which means they add up to something. So the 132.
Can we go back to what you just said about add up to the sum or whatever?
When we're dealing with these problems, there's 3 types of problems. Either
Or just what we're working
just in
on?
general, any sort of word problems.
Okay.
No, some of them actually have. There's a 4th type that I haven't mentioned yet, but I'll get to that in a second. When you're dealing with either you have numbers that are going to add up to make some sort of a total or some sort of a sum, or you got 2 numbers where they give you the difference between them, so they're going to subtract to make this difference, or they're going to be equal to each other. Like sometimes we have angles that must be equal, and we have formulas for them, so we solve. Or there might be some sort of a set formula. You know, when we did the rectangular perimeter problems, we had that formula: P equals 2L plus 2W. If we did simple interest, you know, I equals PRT and stuff like that. You have a formula you plug the numbers into. In this case, you could say that there's a formula, but it's also just the fact that it's a sum. When we're dealing with perimeter, the sides add up. So if the perimeter is 132, 132 is equal to x is the first side, plus x plus 49 is the second side, plus x plus 50 is the third side. And now we're going to combine whatever we can combine, which nothing on this side. X, and x make 3x. Look at this. 1x, 1x, and 1x add up to 3x. Plus 49 and 50 make 99. Then we will subtract 99. So 33 equals x. And then, sorry, 33 is 3x. Then we divide by 3, right? 11 equals x. So we're all done, right? Time to go home, be happy? No, what do we still need to do? We need to plug it in. On the first side, it's just x. So that's good. That's all we need is 11 for x. Yay. The second side is x plus 49. What's 11 plus 49? 60. And the third side is x plus 50. What's 11 plus 50? 61. And we're done. Say yay. Okay.
Would you go back?
Sure. Here's what I want to go over. Number 9. This is also an example of that first type of problem where we have two things that add up to a total. So look at these. We have those two angles, and their relationship is they add up to 180. So 2x minus 1 has to add up with the 5x minus 1 to get 180. Now what do we do?
Well,
So 2x and 5x make 7x. Then what? Negative 1 and negative 1 cancel out? Say no. That's negative 2. They're on the same side. We're combining them. Negative 1 and negative 1 make negative 2. Yeah. Yeah. So what's that? Yeah, they equal 180. I was skipping a step. Now we're going to add the 2. See what hurts? So we add 2 to the other side. 182. Then what? Divide by 7. So x equals 26. So we're all done, right? Well, it does ask what's x. So 26. That's all it asked for. It didn't ask for the angles. So you got to be careful to make sure you know what it's asking for. I don't want to do that one. Don't feel like doing that one. Write in fractional notation. 23.079. What do we do with the 23? Remember, the part before the decimal point is the whole number part of the mixed number. So that is just 23. 79 over, remember, it's the last place value. Tenths, hundredths, yeah, you got tenths, hundredths, thousandths. Remember the other trick we learned yesterday was if there's 3 decimal places, there would be 3 zeros. Now, can we reduce that at all?
well,
Say no. No. 79 cannot be divided by anything.
you know, it turns out to be a really big fraction. 1,000 times 23 plus 79.
Well, yeah, it's 23,079 thousandths. Or it's just 23 and 79 thousandths. Next one here. Oh, more difficult one. Oh, comparing decimals, you guys can handle that. Rounding to the nearest hundredth, of course, that's 956.26, right? Cool. Come on, where's the tough stuff? Adding? You guys have any problems adding the decimals? Well, I think we're good. Unless there's anything you guys can think of that you need me to go over. I think we're okay. Ones to be careful of, this one's like this. I would want to mention this one quick. Negative 372 minus, or 3.72 minus a negative 2.11. What operation are we actually doing here? Plus a positive. Very good. So this is negative 3.72 plus 2.11. Now we still got to figure out what we're doing with this. And I always refer back to that number line in those vectors. Here's 0. Negative 3.72 goes left or right? It goes left. The positive 2.1 goes to the right. Is it longer or shorter? It's shorter. 2.1 is shorter than 3.72. But we know, so this tells us that our answer is going to be negative because we stay on the negative side of 0. And to find the size of the answer, it's the difference between 3.72 and 2.1. So I do 3.72 minus 2.11 is 1.61. So negative 1.61.
It was real easy till you started talking, then my mind closed. I just didn't know what
Well, you can just punch it in the calculator and it'll spit them out too.
I did.
Okay. Well, and some people can look at them and they just make sense, but those negatives for a lot of people are a real hang-up. Okay, with that, you got a quiz due today by 11:59 p.m. and you got new homework due for Monday.
Oh,